A secure platform team uses a private Azure Machine Learning registry whose associated ACR has public access disabled. An engineer tries to create a new environment asset directly in that registry from local files and the operation fails, even though network connectivity to the VNet is already in place. What is the best next action? Option A, assign the registry contributor role to the deployment identity. Option B, create it in a workspace, then share it to registry. Option C, add inference_config before registering the environment. Option D, reference the environment by at latest instead of an explicit version. The correct answer is option B, create it in a workspace, then share it to registry. A company provisions Azure Machine Learning infrastructure through GitHub Actions across dev and prod. Security requires minimizing credential exposure, and production deployments must not start until an approval gate is satisfied. Which two changes should the team implement? Select 2. Option A, keep a reusable client secret in repository variables for all environments. Option B, use GitHub environment secrets and required reviewers for production. Option C, assign owner on the subscription to avoid role troubleshooting. Option D, use federated credentials with Azure login instead of long-lived secrets. Option E, hard-code tenant and subscription identifiers in the YAML file. The correct answers are option B, use GitHub environment secrets and required reviewers for production, and option D, use federated credentials with Azure login instead of long-lived secrets. A team is deciding how to collaborate on notebooks in Azure Machine Learning. They want a model that allows shared notebook content without incorrectly assuming that one user's development machine is a shared team workstation. Which two statements are correct? Select 2. Option A, a notebook must always be run from the same compute instance that originally created the file. Option B, files in the workspace can be used from many compute instances in the same workspace. Option C, a compute instance is intended to be shared by multiple notebook authors at the same time. Option D, only users with owner access can edit notebooks in the workspace. Option E, other users can open a shared notebook and run it on their own compute instance. The correct answers are option A, a notebook must always be run from the same compute instance that originally created the file, and option E, other users can open a shared notebook and run it on their own compute instance. A team is improving a customer support prompt flow stored in GitHub. They created 3 alternative prompts for one LLM node and want to choose the best one using a representative dataset, measurable results, and a fair comparison that isolates the prompt change from unrelated flow changes. What should they do next? Option A, run each prompt once manually and pick the most fluent-looking answer. Option B, submit a batch run for that node's variants with an evaluation method. Option C, change variants on every LLM node and compare the combined outputs. Option D, merge all 3 prompts to main and compare production complaints later. The correct answer is option B, submit a batch run for that node's variants with an evaluation method. A machine learning team wants a working model for early project work that stays interactive at first but does not trap the entire life cycle inside ad hoc notebook execution. They want researchers to explore data and test ideas quickly, then move to managed cloud execution once the approach stabilizes. Which design is the best fit? Option A, keep all training and life cycle work permanently inside one notebook session. Option B, start with endpoint deployment and use the deployed API as the experimentation surface. Option C, register every model candidate before running any exploratory notebook code. Option D, use notebooks for exploration first, then submit command jobs for scalable training. The correct answer is option D, use notebooks for exploration first, then submit command jobs for scalable training. Your team is designing deployment standards for production inference. They want to capture the platform distinctions that matter most when choosing between real-time and batch-managed inference patterns. Which two statements are correct? Select 2. Option A, batch endpoints are the preferred option for synchronous low-latency API scoring. Option B, A single online endpoint can host multiple deployments for controlled rollout. Option C, managed online endpoints require you to run and patch the serving infrastructure yourself. Option D, batch endpoints can only deploy models and cannot deploy pipeline components. Option E, batch endpoints can operationalize pipeline components as deployments. The correct answers are option B, a single online endpoint can host multiple deployments for controlled rollout. And option E, batch endpoints can operationalize pipeline components as deployments. A company wants retraining to start only when a model monitor actually breaches a configured threshold. They do not want retraining to start after every scheduled monitoring run. Which two changes best support that design? Select 2. Option A, subscribe to all workspace events with no filters. Option B, use the event grid event type run status changed. Option C, keep the old dataset drift detected event type. Option D, trigger retraining directly from the monitor schedule. Option E, filter on Azure ML_model monitor threshold breached. The correct answers are option B, use the event grid event type run status changed, and option E, filter on Azure ML_model monitor threshold breached. A team wants to deploy a partner model from the model catalog that must run on dedicated compute in their subscription. They already have compute quota available and are prepared to pay for uptime rather than only per token consumption. Which deployment option is the best fit? Option A, standard deployment in Foundry resources. Option B, serverless API deployment. Option C, managed compute deployment. Option D, a workspace registry without an endpoint. The correct answer is option C, managed compute deployment. A team is formalizing standards for prompt comparison before merging changes into the main branch. They want two rules that are directly supported by Microsoft's prompt flow guidance and that reduce noisy, non-repeatable prompt evaluations. Which two statements are correct? Select 2. Option A, variants are currently supported only in the LLM tool. Option B, to compare variants fairly, change all variant-bearing nodes in the same run. Option C, prompt flow evaluation datasets for batch testing can be CSV, TSV, or JSON. Option D, visual inspection replaces the need for evaluation metrics on representative data. Option E, prompt variants should never be stored in version-controlled flow artifacts. Let's see the answer. An engineer is automating workspace creation for a secure environment that uses managed virtual network isolation. The deployment fails with an error stating that the subscription is not registered to use the namespace Microsoft.network, even though the resource group and region are valid. What is the best next action? Option A, register Microsoft.container registry and rerun the deployment. Option B, grant reader on the key vault to the workspace name before creation. Option C, move the storage account to a different Azure region than the workspace. Option D, register the Microsoft.network resource provider in the subscription. The correct answer is option D, register the Microsoft.network resource provider in the subscription. A central ML platform team runs separate dev, validation, and prod workspaces with tight change control. They want one approved environment supply chain, explicit version promotion, and minimal drift across workspaces, while still supporting private networking and future rollback. Which design is the best fit? Option A, promote approved environment versions through a registry and reference explicit versions. Option B, use only curated environments because custom environments cannot be reused across workspaces. Option C, duplicate workspace local environments and reference at latest in every stage. Option D, install packages directly on compute clusters and document them outside Azure ML. The correct answer is option A, promote approved environment versions through a registry and reference explicit versions. A platform team stores bicep files for an Azure Machine Learning workspace, storage account, key vault, and container registry in a GitHub repository. They want provisioning to run automatically after approved changes reach the protected branch, and they do not want long-lived Azure secrets stored in the repository. Which approach should they use? Option A, run notebook jobs that create resources interactively from Azure Machine Learning Studio. Option B, manually build each environment in the portal, export templates afterward, and reuse those exports. Option C, use OIDC-authenticated GitHub Actions to deploy Bicep from protected branches. Option D, launch training pipelines that create infrastructure before each experiment. The correct answer is option C, use OIDC-authenticated GitHub Actions to deploy Bicep from protected branches. A team deletes the wrong Azure Machine Learning workspace during a production cleanup window. The workspace used shared enterprise storage, key vault, and monitoring resources that the team does not want removed, and the organization had soft delete enabled for the workspace. What is the most accurate expectation? Option A, recover the soft deleted workspace and keep the dependent services in place. Option B, recreate the entire resource group because workspace deletion automatically removes every dependent service. Option C, restore the workspace from Azure Container Registry because registry recovery rebuilds the workspace metadata. Option D, use Azure Machine Learning Studio to undelete the workspace directly from the workspace home page. The correct answer is option A, recover the soft deleted workspace and keep the dependent services in place. An enterprise uses one GitHub repository for Azure Machine Learning Platform IAC. Security requires no long-lived Azure credentials, pull requests must show proposed infrastructure changes without applying them, and production applies must wait for approval before creating or modifying resources. Which design is the best fit? Option A, OIDC GitHub Actions with PR what if and approved main deployment. Option B, let data scientists provision shared resources from notebooks and review the portal afterward. Option C, run nightly training jobs that recreate the workspace and attached services from SDK code. Option D, store a subscription-wide service principal secret in the repo and deploy from any branch. The correct answer is option A, OIDC GitHub Actions with PR what if and approved main deployment. A review board needs to compare 6 completed training jobs before deciding which candidate should move forward. They want to inspect metrics, parameters, and tags side by side, and they also want to save the comparison so the same layout can be reused at the next review. What should the team do? Option A, export outputs for spreadsheet review. Option B, register every run before reviewing. Option C, compare selected jobs in Studio. Option D, send run logs to Azure Monitor. The correct answer is option C, compare selected jobs in Studio.